Hello. This video is going to be about balance and where our sense of balance comes from. So please be aware that I'm talking about the inner ear here, okay? So the inner ear consists of the cochlea, the vestibule, and the semicircular canals. So those are the three parts of the inner ear, okay? And what you need to know is that we are first going to talk about what happens in the vestibule. And the vestibule is going to be responsible for giving us what we know as static equilibrium. So static equilibrium is the equilibrium that you have, which equilibrium means like balance, based on you being still when you're not moving. So sitting in a chair, standing. All right. And if you think about when you're standing, as you start to lose your balance, your toes will help balance you. And it's something we don't even think about standing up. But now imagine trying to stand a baby on their feet, right? You would watch them just fall over because they don't have that equilibrium figured out yet. So in the vestibule, there is a specialized epithelium. Remember, epithelial tissue lines and covers things, okay? And this is called the macula. And again, we're going to find that this is like a mucus-like, gelatinous-like layer. And sure enough, you are going to have little hairs underneath, similar to the organ of Corti, that are going to pick up on the movement of something we call otoliths. Those otoliths are little weights, and those little weights look like crystals. So that's what the crystals look like under an electron microscope. And those crystals are going to be sitting on top of that gelatinous mucus-like layer, right? Similar to the tympanic membrane in the cochlea, okay? And then if you notice underneath here, we have these little hairs, and these little hairs are embedded in that gelatinous material. And of course, these are going to be connected to the nerve fibers, and then the nerve fibers are going to run to the brain. All right. So very similar to all of the other parts of the ear we talked about, you are going to have these little hairs that are going to detect movement of the otoliths. So gravity is going to pull those otoliths down onto that gelatinous layer. And when they're stationary, those nerves are sending signals that you are balanced. When you tip your head back or look up, those otoliths are going to slide across the hairs, stimulating an action potential to be generated and sent to the brain, telling you that you're off balance. All right. So again, this is static balance. This is what happens when you are not moving, but just keeping yourself upright. Okay. So when the head moves, the gelatin and the otoliths move. This causes those hairs to bend, and that initiates the action potential going towards the brain. So that is your static balance. Next is your dynamic balance. And I want you guys to think about the fact that we live in a three-dimensional world, right? We live in 3D. And if you think about that 3D, we have length, we have width, and we have height, basically, are our three dimensions. And sure enough, these semicircular canals, one of them is 90 degrees from the other one. And the third one makes up the third dimension. So in your ears, right, here's the ears, and here's the inner ear. You have these semicircular canals that when you move your head to the left or right, down or up, or to the side, your semicircular canals will pick up on that. So anterior, posterior, and lateral And inside, there is lymph, endolymph. Lymph is a fluid. Remember, we talked about our lymph nodes. We talked about that lymph fluid a little bit in our bodies. And that fluid is going to circulate through the semicircular canals. And in one part of the semicircular canal, we have something called the cupola. And that is going to be a large, comparatively, bump that appears in the middle of your semicircular canal. And I'm hoping that you're guessing in this cupola, there's going to be all of these little hair cells that are going to be picking up on the movement of the fluid going over it. They're connected to the nerves, they go to the brain, okay? So the semicircular canals are placed at right angles to each other. At the base of each canal is something called the crista. Each crista contains hair-like structures called the cupola. And here we have the gelatinous material again, the gelatin. It's going to be like a mucousy, sort of not solid, but not liquid. And when we say solid, solid means that it has its own shape. And Jell-O would be considered a solid. But if you put Jell-O into a glass, it would take on the shape of the glass. So it's really controversial whether Jell-O is a solid or not. But I hope that you understand my point, okay? It's soft, but it does have some stability to it, all right? And then when you move around, that fluid is going to flow through those semicircular canals. So I want you to think about winding up on a swing. I know I talked to one of my class periods about this. If you lay down on I used to lay my stomach on the swing, and then I would wind myself up, and then I would let go, and then I would unwind. And then at the end of it, I would stand up and I would still be dizzy. And I would still be dizzy because the fluid is still moving through those semicircular canals. Okay, so your semicircular canals are going to be what give you your dynamic balance. Sorry about rolling the screen there. Your dynamic balance. Okay, so this is going to be what allows you to run, ride a bike, all of those good things. And again, dynamic equilibrium is while we're moving. All right, so we have our cupola, and we have those hairs, all right, and they flow through the semicircular canals, or the lymph flows through the canals, and as it passes that cupola, you get the sensation that you're moving. All right, so that's our dynamic balance. And if you have any questions, of course, make sure that you stop the video, put the comments in the chat, or send me an email, or be brave and unmute yourself and ask a question. That's always good. The last thing I'm going to cover here really quickly is ear disorders. And I will tell you that ear disorders can be something called conduction deafness, which means the vibrations aren't getting through. You can have sensory and neural deafness, which means that your cochlea is not sending messages to the brain. Okay. If you have conduction deafness versus sensory deafness, the treatments are different. This top picture here is what hearing aids have looked like over the years. And this one right here was very large considering, and it would go over the back of the ear, and you can see kind of what it would look like there. Now this is in the when the young lady with the ponytail there, this is actually part of what we call a cochlear implant. And this one up top is not going to have the part attached to the head. Okay, this one up top here is just going to magnify or Yeah, going to magnify the sound. Okay, these are hearing aids that just simply make things louder. And they got smaller and smaller over time. This one here is the one that I mentioned goes in the ear canal, and you barely even see it when you look in the ear. You have to look really hard in the external acoustic canal in order to see those. Okay, so this is conduction deafness. And that means that you're having trouble with the movement of the sound waves, okay? There are some surgeries that can help. I know that I've been diagnosed with what is known as surfer's ear, and the bones here and here are starting to grow closed, which if they do surgery, they remove the bone and open the external acoustic canal for me, or for a person with surfer's ear. But that would be the surgery, and then otherwise they magnify the sound. Whereas sensory neurodeafness means that the cochlea isn't working. And this thing here on the back of the head is known as a cochlear implant, and it actually is wired into the brain. This young lady can take this and this off. It is connected by this wire here. And to shower, swim, those sorts of things. But when it comes off, she's deaf. And when it snaps back on, then this right here is taking the sound in and passing it to the electrodes that are wired into her brain. So when this was first put on her, they had to do a brain surgery, and they had to wire something into her brain. And then when this comes off, she has literally a snap on her head. So this snaps to her head, and then she can hear. Super bizarre, okay? This is what it looks like on a young child. You can see his was placed more a little bit to the side of his head, a little bit closer to the ear. You can see this part is much larger. I believe that this is an older model, okay? Because they are getting smaller and smaller. I remember the first year I taught at Santa Ana High School, I had a student that had a snap on his head, and he had a very short haircut, so you could see the snap, and I didn't know what it was. I was teaching biology then, and very interesting. Over time, I realized that he had hearing difficulties, and then I realized he had this cochlear implant he wasn't wearing. But again, it was just like this little snap on his head. Very, very interesting and great that we can help people that are deaf hear again. Okay, the next thing that is on our list of disorders is ear infections. And if we look at this right here, this was the picture I showed you at the beginning of this lecture. Maybe this would be better in yellow this time, okay? So that's a normal membrane. And then here we have inflammation. You can see how red and angry it looks. Here we can see the membranes bulging. Here we can see that we really have a problem. This is chronic, meaning that it's happening over a long time. There's lots of inflammation. This is damaging the tympanic membrane for certain. This is the shortened term for the swelling in the ear, the infection in the ear. This is starting to look a little bit better. It's late and it was severe. So it would be almost like this clearing up is going to clear up to this. And if you're not careful, it'll end up with scar tissue on your tympanic membrane, which will change what you hear. So you want to resolve ear infections as best you can. Doctors told me when Darla was little, my daughter was little, that they prescribed way too many antibiotics for ear infections. So they started giving drops that you would put in your ear. And sure enough, Darla did lots and lots of drops over time. And she doesn't have any scar tissue because she got treated for the ear infections she had. So it's really important that you get treated for the infections that you have. All right. Last but not least, motion sickness comes from your ears and your eyes not agreeing on what's happening. So if your eyes are telling you that you are balanced and you are not moving, like when you're reading a book, but your ears are telling you that you are moving because you're riding in a car or in an airplane or on a boat, then your eyes are telling you that you are still, but your ears are telling you that you're in motion. And this is where motion sickness comes from. We're not exactly positive as to why you get nauseous and vomit and turn a really grinchy green. When I first learned of motion sickness, I didn't realize people actually turn green. And when I used to work outdoor education, we used to take children out on a whale watching boat, on a specialized boat for ocean adventure. And sure enough, students would walk up to me, and if they were literally grinchy green, I knew that they were completely seasick. So I don't know why you turn green, but you really do turn green, and motion sickness can be resolved if your eyes and your ears can be at one. Then the motion sickness goes away. So if you're ever motion sick, you want to watch the horizon, you want to see the movement. If you're on something moving, you need to see the movement in order for both of those things to agree. Okay, so this concludes our special senses. We've gone through our balance. I've now covered ear disorders, which I need to throw into the mix of things. I hope that if you have any questions, you'll ask. And I hope you all have a great day and stay well. Thanks for watching.